This is problem 3 from chapter 13. If you would like to give this problem a try on your own, I think you should be able to do it successfully. And I'm going to go through the solution for this rather quickly. So we have a crate, and the coefficient of kinetic friction between the 50 kilogram crate and the ground is 0.3. We want to determine the distance the crate travels and its velocity when t is equal to 3 seconds. The crate starts from rest and the force P is equal to 200 newtons. So we want to find the velocity when time is equal to 3 seconds and we're told it's from rest. So when t is equal to 0, the velocity is 0. We want to find the distance that it travels, so you don't necessarily have to say that it starts from 0, but if I say it starts from 0, then I can just say that I'm looking for s when time is equal to 3 seconds, which just makes it easier. This 200 Newton force is at an angle of 30 degrees, so you want to break it down into x and y components, and you have 100 for the y component and 173.2 for the x component. That would just be using sines and cosines. The force of gravity is 50, which is the mass, times 9.81. You have the normal force acting upward, and you have the force of kinetic friction, for which we have the coefficient of kinetic friction. Looking in the y direction, you have the normal force is equal to, the normal force plus 100, which are the sum of the upward forces, is equal to 490.5, so the normal force is equal to 390, therefore the force of kinetic friction is 0.3 times 390.5, which is 117.2. If you look at the sum of the forces in the x direction, which is equal to the mass times the acceleration in the x direction, you have 173.2 minus the force of kinetic friction, which is 117.2. Therefore, the acceleration in the x direction is 112. So at that point, we finished everything that we can do with Newton's second law, and the rest is just kinematics. So because a is equal to dv dt, we can say this is true. You integrate the acceleration to get the velocity, and you have 1.12 times t. And you can integrate that to get the position, and you have 1.12 times t squared divided by 2. Then you can just take these two equations and put in 3 seconds for the time, and that gives us 3.36 for the velocity at 3 seconds, and the distance that the crate moves is 5.04 meters.